We're going to look at the product rule for differentiation. This is when you've have to differentiate something that's a product of two functions. Here, we've got one function and another function. And although I could expand all this and then differentiate it by multiplying it all through, it would take a long time, and it's a lot quicker to use the product rule. What the product rule says is that if y is a combination, a product of two functions, u and v, then to differentiate y with respect to x, you differentiate u first and multiply it by v, and then you differentiate v and multiply that by u. More formally, we denote that as this: v du by dx plus u dv by dx. So let's look in practice about what that would look like with our example. So, in our situation, we could say that u equals x cubed and v equals x plus 1 all to the power of 5. Now, if we differentiate u with respect to x, we're going to get 3x squared. And to differentiate v with respect to x, we'd use the chain rule. And if you remember how to do that, we're first of all going to differentiate what's inside the brackets. The derivative of that is just 1. And we're going to multiply it by 5 times x plus 1 all to the power of 4, which is what would happen if this was a to the power of 5. If I did the derivative of that would be 5 lots of a to the 4. And that's what I've done here. And that would be 5x plus 1 to the 4. Now, what my product rule says here is that if I have v and I multiply it by the derivative here and add u multiplied by the derivative here, that will give me dy by dx. So I'd have dy by dx equals x plus 1 to the power of 5 multiplied by 3x squared plus x cubed multiplied by 5x plus 1 to the power of 4, which, if I take out common factors, is x squared, x plus 1 to the 4, times by 3 times x plus 1 times 5x, and that simplifies down to x squared, x plus 1 to the 4, multiplied by 8x plus 3. And that would be the derivative of my function y. So using the product rule, what you're looking at is y is a product of two functions. You do the derivative of both functions, and you multiply the original function by the derivative of the other in each situation, and the dy by dx is the combination of these. Okay. Sometimes you're asked to find the derivative of a fraction of a function divided by another function, and in this situation we use the quotient rule. What the quotient rule says is that if you've got two functions, let's call them u and v, then to find the derivative with respect to x, first of all you multiply v by the derivative of u, you take away u multiplied by the derivative of v, and you divide the whole thing by v squared. Now it's really important in this situation to remember to put v first with the derivative of u. The way to remember this is that v for victory. If you're going to be the winner, you're going to start with v for victory, and that's how you're going to start this. So, let's look at our example here. In our situation, our u is our top here, and our v is the denominator. Let's differentiate both of these with respect to x. Okay, so dy by dx. First of all, I need vu du by dx. So that's v multiplied by du by dx. I subtract u dv by dx, and that's all divided by v squared. Okay, if I just tidy that up a bit, I'm going to get 7x cubed times 4x plus 9 minus x all over x plus 9 squared, which is going to be 7x cubed multiplied by 3x plus 36 all over x plus 9 squared. And if you have a look inside the brackets, they've got a common factor of 3, which I should really take out. So I've got 21x cubed x plus 12 all over x plus 9 squared. Okay, so with the quotient rule, the key things we have is that with your functions, you've got u over v, and you must make sure that you differentiate both of them and that you start with victory. You start with your v multiplied by du by dx. Okay, now you have a go at the tasks I've given you.